I'll be talking on intelligent integrated pressure regulation in endourology and some experience on MIMER system. These are my disclosures. For endourology, we have a very significant advancement. Starting from sensors, we have miniaturization of the sensors that allows it to be inbuilt into flexible uteroscopies, like the Elite and some of the brands from mainland China as well, which allows real-time accuracy, but the issue of cost effectiveness is to be investigated. After having these mini sensors, that's with good engineering, we have inbuilt it into flexible uteroscopies. There's automation, which means there are different checkpoints that allows safety mechanism. Without manual intervention, we can still maintain an optimal level of IRP. And just as the AI progress, we have algorithms that, based on the real-time data feedback, we can have dynamic adjustments and enhance the pressure regulatory system. So talking on this topic, first we'll look at pressure. Pressure transducers in urology is actually very well established. We've been using it for many years in urodynamic studies. But with these new sensors being miniaturized, different sensors are incorporated into intrarenal pressure devices. These pressure sensors can be classified into piezoresistive, capacitive, optical fiber, resonant, and piezoelectric types. For the URS, they use the optical fiber, and for the other new type of sensors that measure via the fans, the ureteral access sheath connecting to a system, it's via another piezoresistive type. So I think we all know intrarenal pressure. Previous studies are based mostly on animal studies, where the 30 millimeter mercury cutoff is all from these experiments in the animals and labs. So hopefully with these new devices, we can repeat and find more clues on the mysterious intrarenal pressure in clinical studies. This is one of the publication in press. Um, we look at the classification of intrarenal pressure monitoring devices. So classically, we can only monitor during antegrade manner, which is via a PCNL sheath or a nephrostomy pigtail catheter. But now we're able to do it non-invasively in a retrograde manner. Professor Trexler's team uses pressure wires. And now I'll focus a bit more on some experience on scopes as well as sheaths that's connected to some systems. The top two pictures shows IRP monitoring flexible URS. So in the circle area, we can see the distal tip of the Elite scope. The sensor is located at the lateral side of the scope. Engineers put it there to reduce the chance of being damaged during lithotripsy. Another brand is a Zebra scope from Happiness Works, has the sensor located at the distal tip. It's a smaller French size scope. These inbuilt with optical fiber pressure sensors that works with a fiber interferometer. As for the lower two images, you can see the IRP monitoring fans with different fans design. You can see on the left side, the ZSR MIMER system has multiple holes that is conducted to a tiny channel that's inbuilt into the fan's access sheath. Whereas another brand shows another tiny channel with a single hole that transduces to the sensor, which is connected to the system. It's connected to a piezoresistive silicon pressure sensor that converts the transduced pressure signal into a voltage output that's output on the interface. So just now we are mentioning that is it possible to make inbuilt these sensors into smaller scopes? So the answer is yes, there is quite a number of scopes that are smaller with the inbuilt sensor chip at the scope tip. The range of pressure is actually ranging from -30 or even -300 for the other systems, but in the scopes is from -30 to up to 300 millimeters mercury. They have different sampling rates. They do have alarm, but there's no intelligent systems. So these scopes allow irrigation via the working channels, but there's no suction, no alarm. There's alarm alert and also intelligence. As for the new systems, they measure IRP via the fans, which is connected to the processor, and it has both suction, integrated irrigation via that's connected to the scope, as well as alarm and intelligence. Ben has shown a lot of videos on the Elite system, but I would just like to draw your attention that there's only a flashing triangle, yellow triangle when it's above the set value of 30 millimeters mercury. On the right side, I'll show you the zebra scope. If you see the red value, the IRP, real-time IRP is more than 30 millimeters mercury, which is the set value, and it's only flashing in red. There's no intelligence or feedback mechanism as to how to regulate it back within safety limits. So focusing on a bit, the IRP monitoring fans is just like any other fans, but with an extra channel. That's a tiny, very tiny channel that's capped in the red cap. If you uncap the red cap, you can connect it to a sensor device, which is the gray one, and connect it to the system. It is calibrated with a liquid in the channel. If you do not have these IRP monitoring fans, you can still use it with normal fans. There's an evolution of access sheath as well as flexible URS. You can see in traditional access sheath, after fragmentation, we have to basket out every single sizable fragments. With fans that came out in 2023, you can see we can suction out a cluster of fragments within the sheath repeatedly. But with IRP monitoring fans, we can control the system and make it more efficient and safe. You can see in the operating theater on the right side of the video, we start to prime the IRP monitoring channel with normal saline, so that is fully primed and flushed with saline before connection to the sensor and to the system. So it works really efficiently. The location that I've previously mentioned of these pressure measuring ports on the IRP measuring monitoring fans are different, varies from brand to brand. For the rightmost, it is a ZSR MIMER fans. There are multiple small, tiny channels that's transducing the pressure to the sensor. There are other brands on the market where the pressure measuring ports are located at the very tip with a single channel, or at the juncture between the relatively straight and flexible part. So the point is, if you are using these fans in the tight ureter, if it's not put across the UPJ, then you might not be actually measuring the accurate pressure. So is it really accurate? The right lower corner shows a scope that measures real-time pressure and real-time temperature. You can see the green value that currently is now of 15 millimeters mercury. If you can peep at the ZSR machine on the left side, it's also looking into a range of 11 to 12. There's only 1 to 2 millimeters mercury of difference between the two devices. And it also reflects where the sensor location is placed, as well as what sensing mechanism and the engineering of the device. I think it also differs between the different calibration to zero of different devices. So even for different IRP monitoring scopes, for example, the Elite calibrates inside water, but others may calibrate to air. So we have to interpret this IRP with care because, for example, on the left side, you can see another brand. This is not the ZSR MIMER. This one shows a single hole that connects to the channel of the IRP. If you look at, there's a tiny, tiny fragment that's just lodged at the inside of the fan sheath. I would be worried that the IRP is not reflecting of the true IRP values. Also, when we're as Ben has mentioned, when we're using fans and we're taking out larger fragments, the RP is down to negative 30 millimeters mercury. But beware, this is not true IRP, but it's not intrarenal, it's intersheath pressure. So we need to look into these with all these new devices. This is a publication that came out a few days ago. We looked into animal study. We look at different calyxes, and we look at the upper, mid, and lower renal pelvic calyx IRPs. And it's actually, there are no significant difference within the system from this study. Moving on to intelligence. This is a video of when I was using other non-intelligent system. The inflow and outflow is not well balanced. When I'm lasering, it kept on collapsing. So I think that I do agree on Dr. Wilson's comment on that it's difficult to use non-continuous irrigation in the current era. Just to navigate you on the interface of the MIMER system, if you look at the interface, the leftmost figures are what you can set. You can set the irrigation pressure, irrigation flow. You can set the negative suction pressure and flow, as well as the cavity pressure, which is the IRP pressure. You can set a maximal threshold, and it will intelligently control it within this value. You can look at the real-time pressure when everything is connected, the real-time irrigation, flow and pressure, suction flow and pressure, as well as the real-time intrarenal pressure. So the MIMER system, if you use their irrigation tubing connecting to the ureteroscope, you can see there's continuous flow. It's not a pulsatile flow, which allows for a stable IRP. You can see that the values keep on jumping around in the middle of the screen because it's regulating and keeping the pressure at a safe range within 30 millimeters mercury. And it acts with a pump and an algorithm. So it's intelligent because when you're connected to the IRP sensor, you can see at the right lower corner, there's a gray thing plugged in to the pressure sensor. And the red circle shows the real-time pressure. We manually make it more than 30 millimeters mercury. If you look at the pump at the blue arrow, it automatically stops pumping when it's above 30 millimeters mercury. So it's a safety mechanism so that it's not a forever inflow of fluids throughout. For suction modality, I think a lot of us may be using wall suction, but the wall suction may not be very stable. If you set it at a certain pressure, it may not be actually suctioning at that pressure. And it may varies if a lot of people are using the centralized pressure at the same time. There are other devices such as the Neptune, which gives suction at graduated pressure, and you can more or less have a more steady negative pressure coming out. It also have intelligent suction. If the nurses connect the tubings incorrectly and there's backflow of fluid into the system, it will give you alarm and stop as well. So in essence, I'll just give you a brief idea of how you can precisely adjust your irrigation settings. So it was collapsed at the very beginning. So I've asked the nurses to kindly adjust the pressure settings for me. So it's a very user-friendly system where you can just touch screen and adjust the irrigation easily. So this is actually a patient that has received surgery under local anesthesia. And you can see the patient is actually lying very comfortably in the operating theater. The RP value, if you can see at the right lower corner, it's less than 10 millimeters mercury. And when we start lasing, it's still within 30 millimeters mercury. We can also adjust the suction levels by pressing on the touchscreen. So negative 200 millimeters mercury of suction is quite too much. It was collapsing the system a bit. So we can easily instruct our nurses or allied staff to help with adjusting to another level when as appropriate. So when everything goes well, you have these dust. Actually, it will create a good continuous irrigation with moderate suction and allow you to dust out, clear out all the fragments and dust. You can see throughout the operation, we can adjust the intrarenal pressure of less than 30 millimeters mercury. And towards the end of the surgery, you can see this is a dust-free operation with good, safe RP. And the patient had minimal, like pain score of just 1 throughout the surgery. Immediate dust-free with as shown by the non-contrast CT scan, it's possible with current technology and devices. This is a glimpse of what the technology can offer. We can now measure real-time intrarenal pressure. And how do we use these devices and monitor them properly? I think we need to train and look further. More studies are to be conducted. I think the users need to have a thorough understanding of these devices prior to use, especially there are quite some troubleshooting when you use these devices. And we have to be intelligent on how to interpret these real-time intrarenal pressures. And I look forward to future work with these optimal fluid dynamics for best and safe, efficient outcomes. I hope you're not too confused by all the panel of things that I've shown throughout the videos. It's not like driving an aircraft. It's not that difficult with all these interface. Actually, we just need to look at the intrarenal pressure. That's the set value of, for example, 30 millimeters mercury. And throughout, we can keep it within check with a real-time intrarenal pressure. And you don't have to care about the other values because it would be intelligently regulated throughout the surgery with these new devices. Maybe this is an all-in-one solution. Maybe we need more optimization of these designs. But in the future, we can look into treating larger stone volumes more efficiently and in a safer way. That's the end of my talk. I would like to acknowledge my team who has supported me with all these new technology, as well as all these groups that I've been collaborating with. Thank you very much.